Hello, and welcome to this video series where I'm going to be making a potato cannon that runs off of hydrogen produced by electrolysis of water. The basic idea for this is a electrolysis cell that splits the output with a wall that's only permeable by current, not the bubbles of gas created, and taking that hydrogen gas produced and running it through a bubbler that will act as kind of a flashback preventer to prevent any flame front from reaching the electrolysis chamber and destroying it, and then routing that gas from the bubbler into the cannon where it can build up behind the projectile and fire it outwards. In this video, we'll be talking about actually making the electrolysis chamber and the design considerations that had to be taken when creating it. So the electrolysis process creates noxious fumes like chlorine and sodium hydroxide. So the electrolysis chamber had to be chemically resistant to prevent any dissolution or destruction of the chamber itself. This is why I made the chamber out of polycarbonate as opposed to maybe a more traditional 3D printing material like PLA or ABS. So here we have the finished product of the electrolysis chamber. The hydrogen is created in this chamber, which houses the negative electrode and comes out of the port you see on the top. On the other chamber, the chlorine is created at the positive electrode housed within it. There's a wall separating the two that prevents the gases from mixing. The chlorine is toxic and pretty useless as far as I'm concerned, so it is vented off to just a separate container. Alright, so the basic idea behind the bubbler is that it's a container of water that will allow the gas to come down through it and bubble back up out of a hose and out of the chamber so that it's effectively separated from the electrolysis chamber. The process would be pretty simple. I'm using a 15/64 drill bit here, but anything with a snug fit to the hose would work just fine. And then I'm going to seal it off with hot glue, and hopefully that'll create an airtight enough seal that'll get gas flow out of the outlet valve. So I will do that. OSHA compliant, guys. OSHA compliant. And check if the hose fits through, and hopefully, professional quality, boys. That will be it. So, if the camera would focus, you can see that the hose fits through quite nicely, and the idea is that it will thread onto the bottle and bubble into the container like that. So here's an overview of the whole system. You have a DC power supply that's running into the electrolysis chamber that has two separate tanks, one for the hydrogen and one for the chlorine, positive and negative electrodes. The electrolyte used is a 25% solution of table salt, which I found via this graph to be the most conductive and therefore have hopefully the most hydrogen yield. The bubbler is shown here, and if this works, it will show the gas flow as it comes through from this chamber right here. So now you can see the bubbler working, and it's clear that it's producing quite a bit of hydrogen, and it's working exactly as intended. So I'm really happy about this result, and I think that's where this video is going to end. In the next one, we'll work on routing this hydrogen into a cannon and building an ignition system so that we can shoot a potato. Alright, bye.